Okay. The majority of 5.5 is all about the coins. Making more coins. How much, if you put some coins to the side, how much you gonna have later? So, with that said, let's look at the first slide, which is this one. So, there's no need for you to remember what the one says in the second bullet because it's covered in the last two. So the topic here is the amount to which an investment grows over a period of time. Don't you want your money to grow? If you put something to the side, don't you want it to grow? Yes, if you put it to the side. Now I understand you're like, I ain't got a whole lot to put to the side right now, but if I had something to put to the side, I do want it to grow. We prefer it to grow fast. Does that usually happen though? No, it doesn't usually happen. Does it take some time? Does it? Yeah, it usually takes a little bit of time. Unless you hit the lottery, then you're good for a little while, right? Okay, all right. So, but in this case, if you have some money that you do want to invest, we're gonna use the last two formulas. The formula that you see here in bullet number 2, it's already included in the third one. So don't worry about this one at all. Let's focus on this one, these two. So we're gonna talk about how to figure out how much money you're going to have in the future using the formulas that you see. S means the amount that you're going to have. You could have put an A or S there. The principal is how much money you have to invest. The R is your rate or your interest rate. Compounding is K, and over time is T. Now, do they have to use these same letters of the alphabet for the variables? No. They could put down here N. They could put an N up here, a T. Just know that this number on the bottom here is always going to be your compounding, and it's always going to be the compounding times the amount of time. Okay? This last formula is associated with when it's compounded continuously all the time, 24/7. So that is the formula you must use if it says your money is compounding continuously. You see the word continuously, you have to use the PERT formula. I call it the PERT formula. Okay, so here is also the next one that you need to look at. Here's the formula for something called the lump sum. I'm going to do examples for these. I just want to make sure we're okay with the formula. So let me write both of the formulas that you just saw on the board because we're going to use these. So you saw S is equal to P times 1 plus R divided by K raised to the KT power. You saw S is equal to P E raised to the RT power.
And what's that? The S equal to P to the...
Wait, which one? S is what?
Yeah.
Oh, what each one of these letters? This is just, I should have put this. This is how much money you'll have in the future. Money that you will have in the future. Okay? Okay, P is for the principal amount, means your initial amount of money that you have to invest. Principal amount of money that you have to invest. Principal amount to invest. Or invested. The principal amount invested. Okay? R is the interest rate. And K is the compounding. K is for compounding. Now again, in the last class, I know you guys heard me say this, so let's talk about compounding again so you'll know. For compounding, how many times a year can you compound? Annually, which equals once a year. Semi-annually, which is twice a year. Quarterly, which is 4 times a year. What's next? Monthly, which is how many times a year? 12. Bi-weekly, which is what? 26 times per year. Weekly, 52 times per year. And then the last one is daily, which is 365 times per year. So, depending on what the word problem says, it might say annually, semi-annually, quarterly, monthly, whatever it says, That's the number you have to put in for K.
What was T for?
Time in years. So T is time in years. Okay, T is time in years. So we're pretty much back at the previous slide, just making sure we understood everything that went on the previous slide.
What's that in there with the R over K?
What is that, 1 plus?
Oh,
It's
that
a
was-
plus, that should be a plus sign.
it was the one that was throwing me off.
Okay, so you made it look, so yeah, that's a 1.
Thank you.
There you go. Are we good? Those are the formulas you're gonna use to determine how much money you'll have in the future. So literally, what do you do with this problem? Plug the numbers in and put it in the calculator. That's it. The only way you get this wrong is what happens?
Put it in.
You ain't put it in the calculator right. So that's the only way you get this wrong. Here is the next formula. This one's called the lump sum investment formula. Why do we call it the lump sum? Because this one wants you to figure out how much money you're gonna need in order to come up with a certain amount in the future. So don't write this formula because I'm getting ready to change it. So right here, in the place of where you see the I meant to change it earlier and I forgot. This should say R over K, like what you saw before. So let me actually copy that part from the previous slide. I need this R over K. So I'm gonna copy it and paste it in the place of this part. Paste. And this should be KT.
So we're gonna have to remember
Mm-hmm.
these.
Mm-hmm. Yes,
You're not gonna have them on the test?
maybe.
I think we should. Because we just never.
That's true. This one's not too bad though.
I mean, it's a lot of just numbers, like, you know what I'm
It
saying?
is, but once you practice it, requires practice. It's like riding a bicycle. You can't ride if you ain't never practiced riding, right? So you still gotta practice some of these. So again, in this particular case, it says the lump sum investment P is what will be needed to give you a certain amount in the future. So let's say you want to buy a car, and this car gonna cost you $50,000. How much money you gotta have today? So if you wanted to buy a car in 2 years, so I'm gonna give you a new car in 2 years, and it's gonna be a $50,000 car. How much money you gotta have today so you can make an investment so you'll have $50,000 in the future? So the S represents the sum of money that you need to have in the future to buy the car. You got it? So let me write this back up here. S is how much money you need to have in the future. P is how much you need to have right now so you can have that much money in the future.
Why do you need it right now?
That's your investment amount.
That's what you, so for example, let's say I got $2,000, but I want a $50,000 vehicle in 2 years. Am I gonna have enough money saved up to invest it to make that much? In 2 years? No, I might be able to buy me a $4,000 car, but I don't know if I'm gonna have, so this tells you, if I say I need, how much money do you need? You got a child going to college in 2 years, you need $20,000. So I got $20,000.
On that second year, is what you're saying?
It depends on what the year is. I'm just saying I made up 2 years. It could be 5
You
years.
need $20,000 on that second year.
However many years it says. It might say,
Situation.
in this situation, I said 2 years. It could be 5 years. It could be 10 years. It just depends on what they tell you the number of years. So, in this particular one, you need $20,000 in 2 years. My interest rate is 5%. It's compounding monthly. And I got 12 times, how many years did I say? 2 years. All right, so I need $20,000 in 2 years. My interest rate is 0.5 or 5%, compounded monthly. So I got to put this in the calculator.
So
Me-
it's a payment? So
Huh?
it's like a savings account.
It's gonna tell you if you put some money to the side, how much you gonna need to put to the side now, so you'll have 20,000 in 2 years. How much you gonna need to put to the side right now, so you can have $20,000 in 2 years.
Yeah,
You
but
start
the
today
interest
going
don't-
forward is what it's
today.
But that's what I'm saying, the interest though, like.
Why is that interest though?
It has to be some kind of.
You gotta put the money somewhere. You gonna put it under your mattress, it ain't gonna go nowhere, right?
Right.
Oh, you said if you
That's
put
what
it into
I'm
a
saying.
savings
So
How
account.
much it
That's
will
how
grow.
savings. Okay.
It could be a savings account, it could be a CD, it could be a particular investment account. It might be your mama gonna give you some interest on it if you give it to her for 2 years. It depends on where you invest in that money. But you gotta put it in someplace other than your mattress. You got it?
So you solving for P,
I need to know what P is, so it tells me how much money I gotta have today.
$1,100.
You got what?
$18,100.
Oh, you did it already. Okay.
18,000 today.
Okay, so how do you put this one in the calculator is a very good question. So for this one, here's how I will put this in my calculator. You should be able to type it just like it is, but the key is making sure you get all of this underneath here. So I would have 20,000 in my calculator, parentheses. And but not for division sign, then parentheses.
I'm really confused.
I put the whole thing in my calculator.
Okay? Some of you all can type it just like this. If you can't type it, if you can type it just like this, go for it. But some of you all can't type it like that. So if you can't type it, I'm telling you what to put in. 20,000 divided by, you need a parentheses because all of this got to get divided by. 1 plus 0.05 divided by 12. Close parentheses raised to the 12 times. This is how you should, if you can't see it in your calculator like this, if you can type it and see it like this, you're good. If your calculator does not let you see it like that, you need to spell it out. It just depends on what kind of calculator you got. If you have a fraction button on your calculator, do you guys have a fraction button on your calculator that lets you do this? If you do, hit the fraction button and type it just like it is on the screen.
You gotta hit the fraction button.
But you gotta hit the fraction button first. So it just depends on how your calculator functions. Monique, you said we're gonna need to have $18,000 right now. If you,
100.
with 18,000, don't miss the 100. You need $18,100 right now if you want to have $20,000 in 2 years. Okay? We're good? That's the end of chapter 5.
That's what it sounds like. Like, why would you be 18,000 right now?
That's assuming that you have that money right now. That's assuming that. That's why I said typically what will usually happen is it takes you more time than that. You like, okay, I'm gonna need more time than 2 years to save this money up. So then you started maybe 10 years ago instead of 2 years ago.
So is this problem basically saying you have 18,100 right now?
They're telling you how much you're gonna have to have right now. It's saying this is what you gotta have if you want to have $20,000 in 2 years. You gotta have this much
Today.
today.
Okay.
You have to already have that much in your savings account right now.
Okay.
That's what it's saying. We okay?
I wish I heard that one.
Me too.
Miss Harris, you got it.
Okay, we are done with chapter 5.
So the other two formulas, we do the same thing, just plug in the numbers.
I'm gonna go back and pick up a couple of problems from the study guide and do those so you can see them. All right, so we are done with chapter 5. I'm gonna pull up chapter 6 and let you see the last parts of chapter 6, which is on the study guide that we're gonna finish the rest of. All righty, there's only 8 slides and we are gonna skip the first 2 because there's nothing on the first 2 of them that you need to know. So we only got 6 slides to do. We're gonna talk about higher degree polynomials. Higher degree polynomials are anything when the highest exponent is bigger than 2. Higher degree polynomials is where the highest exponent for the polynomial or the equation, the highest exponent is bigger than 2. And we're only going to look at 2 different types. One that has the highest exponent of a 3 and one that has a 4. We're only going to look at those 2 types. Could we go bigger? Yes. We're only focusing on this class on the ones that have highest exponent of a 3 or 4. They have special names. The 3 degree one is called cubic. And the 4th degree one is called quartic. Cubic and quartic. Like quarters, quartic. So those are the 2 that we're going to focus on today. In that slide right here, that degree is determined by the highest exponent. So if I say, what's the degree? You find the highest exponent, and that's the degree. The second bullet says, it can have so many x-intercepts. What's the x-intercept again?
Point where the
Where the graph what?
crosses the Y.
Crosses the
X-axis.
x-axis, okay, where it touches or crosses the x-axis. So if it's an n degree, it has n x-intercepts. So let's say if it's a third degree, how many x-intercepts could it have? Look at what it says. If it is degree 3, it has at most 3 x-intercepts. Look at what that says. So in the place of the n, I will put a number. So if the graph is a degree 3, it has how many possible x-intercepts? 3. If it's a degree 4, at the most it could have 4. That's all that says. If it's degree 3, it could have up to 3. If it's a degree 4, it could have up to 4. That's it. That's how many times it could cross the x-axis, right? Okay, alrighty. So with the next one said, let's look at some of the, I'm gonna push this up so you guys can hold on to that one. In the cubic and quadratic functions, they have points, and we call those points maximums and minimums. Do roller coasters have tops and bottoms? We call them maximums and minimums, or turning points. Do roller coasters have turning points? If you're at the top, what are you gonna do? Turn and come back down. If you're at the bottom, what you gonna do? Go up, unless you're getting off. So here's what turning points look like. Alrighty. Here is an example of maximum and minimum. They call these extreme points, and they have maximums and minimums. Well, where are the maximums at?
The ones at the top.
Top of the mountain. These are called maximums. Top of the mountain is maximum. Where is minimum at? At the bottom of the mountain, the bottom of the, what we call it, the valley. So this one is a minimum. These are called maximums.
It's only one minimum because
You only see one curve down. One curve that's going down. So these also are called, what are the other names for this? Can I call these turning points? Yes. These are also called turning points. So wherever you see max and mins, they're called turning points, because it turns and goes the other direction. We're good? We may have mentioned something because we've talked about certain types of graphs. We just didn't spend a whole bunch of time. All right, so this one's called an absolute maximum. Notice the word absolute. Why do you think that was called absolute maximum?
it's the highest.
It's the highest one. So if it's the highest, it's the absolute maximum. If I had two of them that were down here, one would be the lowest, and it would be called the absolute minimum. So this one is the highest, it's called the absolute max. We okay? So it doesn't matter what your graph look like, you're looking for the maximums and minimums. The only way it has an absolute is gotta have two of the same kind. So if you got two mountaintops, one's gotta be the max, one's gotta be the min. Excuse me, one's gotta be the absolute, one's gotta be a local. All right, questions?
And then the absolute minimum is just whatever the lowest one is.
So if my graph looked like this, I'll just put it here. If my graph looked like this,
You got two minimums.
now you got two minimums. So here, in this case, I got one maximum and two minimums. Which one is the absolute minimum?
The bottom one.
The bottom one. So this one's the absolute. Right.
If you only have one minimum point, are they still gonna ask you what's the absolute minimum?
Nope. You can only have absolutes if there's a multiple of the same type. So if my graph looks like this, I got one max and one min. Okay. Remember, max and mins are still called turning points. So on the graph it says, where are the turning points at? You should be naming all of these. That's a turning point, that's a turning point, that's a turning point. Anytime you see the curve go up and turn around and go back the other direction, then it's a turning point. All right, questions? All right, last couple of slides. So here's the cubic one. A cubic function, you've seen this before because we've talked about it many times before. A cubic function, the highest exponent is 3. This is the simplest cubic function you could have. This one right here is the simplest cubic function you could have. So let's create one that's not the simplest one. I'm making this one up, guys. Alrighty? That's the cubic function. Why? Because the highest degree is a 3. The highest exponent is a 3. So it's a cubic function. Bullet number 3 says the basic one is going to be y equals x to the 3rd power. That's the simplest one. How many turning points can it have? Look what it says in bullet number 4. You only got 2 choices. How many? 0 or 2. That's this graph right here. So if you're looking for which one is this one, that's this graph. It's either got 0 or 2. You ain't got no other options. Can't have one, just 0 or 2. So maximum turning, number of turning points. That's what I meant to say here. Number of turning points. That should say points. Is 0 or 2. Okay? All right, the last 2 bullets just says this. If it's y to the negative x to the 3rd power, it opens like this. Can you see the difference between this one? Let me rewrite this one for a second. Oops, I wrote the same thing. Can you see the difference between this one and that one?
So it's like you just flipped it over.
I did. And let me scoot it over closer to this side here. So this is y equals x to the 3rd. And again, it looks like this. What's the difference between this one and that one?
Oh, the middle.
One's going down, I mean, yeah.
Okay.
One's negative.
What's the difference between the
Oh,
equation?
that's right. The way
This
it's
one has a
flipped is
negative,
over.
right. So the negative sign just does what?
Oh, upside down.
That's all it does. So when you flip this upside down, it looks like that. Alrighty? So now in the 2 last bullets, this one says if it's positive in the front, it opens up on the right and opens down on the left. If it's a negative over here in front of x to the 3rd power, it opens up on the what?
Left.
And down opens down on the right. That's what they're asking. That's what they're saying in those 2 bullets. Okay, so that's for cubic functions. How do you know the degree again? The highest exponent. The homework will also ask you for the leading coefficient. The leading coefficient is the number that sits in front of the one with the highest exponent. So what's the leading coefficient for this one? 1. Find x to the 3rd power. Where's x to the 3rd power? In the front. What's the number sitting in the front that you don't see? 1. So if it says what's the leading coefficient, it's always the number that sits in front of the x that's raised to the highest power. Alrighty? So what if I write it this way? Here's my equation. Y equals 8 plus 4x minus 2x squared minus 9x to the 3rd power.
Oh, negative.
Negative 9.
So what's the coefficient? -9. What's the highest exponent? 3. Find the highest exponent, and whatever number sits in front of that is always going to be your leading coefficient. Now, is that written in the proper order? No. So don't assume that it's going to be written in the right order. So you should always be putting it in descending order. So the highest exponent come first, then the next highest, the next highest. So this should be rewritten with the -9x to the 3rd power in the front. So if it says leading coefficient, you're going to say -9. Questions?
So the leading coefficient has the highest exponent?
That's what you should always be looking for this. You should always be looking for that. Highest exponent with the number that sits in front. Okay, questions? All right, almost next to the last slide. Fourth degree polynomials are called quartic functions. The basic one or the simplest one is going to be y equals x to the fourth power. It usually looks like the shape of a W or an M. It usually looks like the shape of a W or an M. Does it have to be a perfect W? No. Will it be a perfect M? No. M or W. That's what this looks like all day, every day. Okay, so now the question becomes, can I write one that looks like it's a little bit more complicated? Sure. So here I've got y equals x to the fourth minus 3x to the third minus 14x squared plus 4x minus 9. Is it still quartic?
Yeah.
Why?
Because that's 4.
Because the highest exponent is a 4. What's the leading coefficient again?
1.
1. Okay. So what if I rewrite it and I put it as negative 3x to the third power minus 14x squared plus 9x to the fourth power plus 2.
9.
Okay, so it's not in order at all. Is it okay that I'm missing x squared? Do you notice I'm missing a term that's x squared? Is that okay? Sure, as long as I know that it's quartic and the highest exponent is a 4 and the leading coefficient is a 9.
So for the quartic, the highest exponent will always be 4 too.
Correct. We're only doing cubic and quartic. Okay, looking at the last 3 bullets. How many turning points can it have? If it's quartic, how many turning points can it have? 1 or 3. Well, look at these two we drew. So this means it could actually, this one could look like, and I'm trying to make it so you can't barely see it. It could look like something that you can't even see the curve that took place down here. So it's going to look like a parabola. It'll look like a U shape. So you won't be able to see any more than just this one point right here. So it's either going to look like this or this. Most of the time they look like this. M's and W's. Most of the time. So it can only have 1 or 3 turning points, not 2. Just 1 or 3. And because it's even, either both ends open down or both ends open up. When do they open down? If this is y equals negative x to the fourth, opens down. If it's y equals just positive x to the fourth, they both ends open up.
So if it's more than, like if it's 2 turning points, we can just assume that it's not quartic.
Correct. There's got to be one of these. Because here are my turning points. 1, 2. 1, 2. So you're absolutely right. If it's got 2 turning points, it's definitely not quartic. All right, questions? Alrighty, so the only thing that you need to know from 6.2, and let me show you that, it's going to ask you to go to the homework and you're going to be given data. What are you supposed to do with data when they give you XY table? You got to put it someplace, right? In this particular topic, they want you to put it in Zuru, but where are you going to put it? Where are we going to put quartic and cubic in Zuru? Well, let's go find out. So this is the last part of 6.2. I'm trying to think of what number I was getting ready to say. The last part of 6.2. All right, that's not where I want to go. All right, so we're in Zuru. What should I click on for quartic and cubic? It don't even say quartic and cubic up here on the screen anywhere. We're gonna go to polynomial. Why polynomial, which is PR?
That's polynomial.
Because they are polynomials, but what makes them cubic and quartic? So
The exponent.
the
So
exponents.
it's just gonna raise the degree.
Thank you. So again, we're gonna go to polynomial, just like Angel said. And at the bottom, when we were doing quadratic, did we leave this as a 2?
Yes.
Yes, but now since we're doing cubic and quartic, we have to change it for cubic to a 3, and for quartic change it to a 4. So if the homework says, can you create this equation? Put your data in here, change it to a 3 or 4, depending on which one it asks you for. That's it for 6.2. That's all you gotta do for 6.2.
Really?
Yeah.
I just got my computer out, you know, I don't have to find
No, we're getting ready to go to the study guide, because I want you to see the problems that look like this from the study guide. Alrighty? So let's go back to where we were with the study guide. Alrighty, so we left off, we did 17, so we're gonna look at 18. 18 is a slightly different one. You won't have one exactly like 18 because it did something that I wasn't expecting it to do when I picked that one. But I'm still gonna go over anyway so you'll see it. Alrighty. Let me see. You don't have what's on this first board up here, but I want you to be able to see the compounding. So I'm actually let me switch boards and write on the other side of that board. Let's put this up top. Alrighty, so I'm gonna write on the right side of the board over here, starting with number 18. Number 18 says, if you have an initial value, now this is requiring that you use y equals the initial amount. I can't remember if we put a y here, but I'll just use y. And it's gonna be raised to the number 18. This is the one that I don't want you to spend any time because it modified what I was expecting to do for this one. And I didn't like how this one turned out. So even though, no, we will not have, it changed the format of the equation of the formula. So I'm gonna go over it, but please skip 18. Okay, so it wants to know what f of t is gonna be is what I'm gonna put here. So do I have a principal amount of money or principal amount that's being invested or decreasing? This is called the decreasing function because it's actually decreasing. So I put a minus sign because it's decreasing. My initial value was 55. It's decreasing at a rate of 46%, which is 0.46. And it says it's decreasing at a rate of 0.46 every week. Oh, you know what? You know what? I just thought about something else. I'm gonna see if that works that way. I'm gonna do it this way and see if it comes out right the other way. All right, this is 0.46. I'm gonna leave it as 0.46. This is happening per week. How many weeks in a year?
52.
52. And again, does it give me a time? T. No, it just wants you to create the equation. They don't even want you to do anything but create the equation for this one.
That's it.
That's all they want you to do is create the equation. So now you gotta simplify this part right here. This part, can you simplify and tell me what this is when you put it in the calculator? It's 1 minus 0.46 divided by 52.
So how did it change the equation?
Because I didn't have one, when I taught it to you originally, when we talked about it originally, it didn't have a K here. It just had a decreasing rate. I didn't put a K there. And I didn't mean to put that one there, but this is the way this problem works out. I want to try it a different way though. So tell me what the answer is that you got there.
0.99.
Okay, so 0.9954. Say it again.
0.9911.
Check it again for me, please. The T stays. It doesn't go anywhere. Remember, look at your answer choices. T doesn't do anything.
I had got a fraction. I'm just doing, you just talking about the parentheses. Right?
Yeah, I just want to know what's in the parentheses. It's going to come out to be a certain.
Fraction.
Turn the fraction into a decimal for me. There should be an S to D button on your calculator that turns a decimal.
I had to get a new calculator, so.
Okay. Somebody else try it for me?
I got 54.513.
Oh, here it is.
It should,
I got point, yeah, I got the same thing she got.
it should come out to be 0.9954.
Point nine nine one.
I got 9911.
Yeah, the same thing she got.
And you put in one, now when you put that in the calculator, did you put in 1 minus and then parentheses around 0.46 over 52?
Well, I will.
Just to see,
You ahead of the game.
let me try that with myself
It's
on.
about the same thing.
Same
Okay.
thing.
All right, let me try something and see where I'm making my mistake at. All right, so 1 minus 0.46 divided by, we did say weekly, right?
Maybe this calculator is faulty.
Nope, so you all got that part right. And also I'm gonna change this slightly because I wanna see, I'm gonna put all of this in my, I'm gonna see if I actually messed my percent up. That's what I think I did wrong. This is minus 0.0046 divided by 52. That's still not the number that I was looking for either.
I got 99.54.
Yeah,
0.9.
that's what I want, the 0.9954. That's the actual,
How'd you get it?
yeah, what'd you put it in as?
Oh, no, that's the first time.
You don't even remember what you,
I got it though.
okay, because I just did this morning, I got the 0.9954. All right, let me think,
You do 1 plus?
it says it's decreasing by 0.46%. So let me try, oh wait,
55 parentheses.
I think,
Yeah,
46.
55 parentheses.
There it is. All right, so here, guys, here's my mistake. We're not dividing by the weekly.
Oh, but that's what I did.
Yeah, that's what you did. Yeah, we're not dividing by the weekly. That's what I thought I was originally gonna do. So this is 0.46%. So when you have a decimal with percent already after it, don't you have to move the decimal 2 places to the left? It didn't say, notice it didn't say 46%, which is 0.46. It said 0.46%, which is equal to 0.0046.
That's a trick.
If it said 46%, you change it to 0.46. If it said 0.46%, it's 0.0046.
54.
So we should be subtracting .00.
Yep, so I forgot to mess my decimal up. It was 1 minus 0.0046 raised to the t power, which is gonna give us that 55 times 0.9954, like we originally said. That is what you should have as your.
Oh, you don't put it on over 56.
55.
Don't put it over 52. That's where I was making my mistake.
But we still skipping this one, right?
Yeah, no, not to worry about it. I'm saying it turns out okay, but it's not one that you have to worry about. Alrighty, back to the study guide. We good with that one? We just put it in the all you needed was the equation. It doesn't want you to plug no numbers in, just want you to get the right equation.
He gave me, is that 19?
This is,
Oh, it's on 18.
this is 18. So 19, you just plug the numbers into the calculator. Please go. It says you got $1,000 invested at what percent? 5%, which I'm gonna change to
0.05.
0.05. Compounding how many times a year?
2.
Twice a year. So the K is gonna be 2. So put that in your calculator as 2. How many years? 7 years. Somebody type it in the calculator and tell me what the answer is.
Like 14.
14, 12, 97.
You got it? You gotta be able to put this in your calculator and get it right.
14, 12, 97.
14, $1,412.97. Answer B for number 19. Did you put it in the calculator right?
If I can see it.
And then what was, let me see, the K.
Remember when we talked about this earlier, that they may not use K and T like I used over here? So they use K for compounding. Remember K is compounding? But they use in the place of the time in years, what letter did they use? N. It's still years, number of years. N represents number of years.
14, 12, 97.
But then it says in the equation.
This is, did you raise it to the power? This is, see where that time sign
Oh, I
is?
forgot that little,
It's gotta be raised to the power of
Seven
whatever that
times.
K. So you should have, so when you put it in your calculator, you should have 7 times 2, it being raised to the power of 7 times 2, which you already know is 14. So just, all you do is change that to a raised to the power of
I
14.
did, I didn't get it.
Put the 14 in parentheses.
okay.
You can. Would you, okay,
Oh, you know what? I did 5. It should have point.
You gotta change your numbers
Yeah,
to a decimal.
0.05,
Yeah, point zero five.
Point zero. You gotta-
okay?
I ain't getting in there. What could I do wrong?
Let's see what you put in.
I punched this
Oh,
one.
it says-
So except I changed that to 14 in parentheses.
Okay, and you hit the raise to the power button?
That's right.
Did you raise, let me see what, no, that's raised to the 2 power. You should have a button that raises it to any power, which is that X to the Y.
Okay.
While you're working on number 19, you should be able to do number 20.
I was doing it and it kept giving me a number that's not on it.
Okay, you already working on number 20?
I must have put the, formula in. The wrong, isn't it the same formula like at
Make
the
it
top?
really small over here.
Oh, you said make it small. You said you couldn't see it, Angel, so I was trying to make it big.
Let me just put it over my computer then. I don't want to inconvenience everyone else, so.
There was no inconvenience and made it big so I could see it too.
Maybe I just need to move up closer. How about I do that?
That's a good idea too.
Yeah, you know, because everybody else, like, I can't see this.
Okay, question. Are y'all working on number 20?
What did you say do about, 20 is the same way?
20 is the exact same way. Whoops. Alrighty, so now what's the difference between 19 and 20? I mean, what's the difference? Did they give you the formula?
Oh, yeah, they gave you the number.
And they gave you the numbers to plug in?
Now you gotta just know.
In number 20, they didn't give you the formula. They're assuming that you already know the formula, but did they give you enough information to plug in some numbers?
And then where the K have 2, you're gonna change it to 12 on 20.
So yeah, on number 20,
It'll be
it's
12.
monthly, so it's gonna be 12. Compounded 12 times a year. So here's what you should be putting in. So I've got, my amount is gonna be 2,800 times 1 plus, what's my rate? 7% divided by 12 months, raised to the 12 times how many years? 5 years? Well, I know that's 12 times 5 is 60, so I would just go ahead and type that as 60. All right, somebody do that in the calculator, tell me what the answer is.
39, 69, 35.
Explain to me what you just figured out. In English. You had,
You initially deposit $2,800.
uh-huh,
After 5 years,
mm-hmm,
at 7% interest, you're gonna come out with
compounded, wait, after 7 years compounded,
compounded
monthly, you'll have
that.
$3,969.35.
So that 2,800 goes where that 1,000 is, where the 19 is.
Correct. Correct.
Still,
I'm so behind.
Is 21 increasing?
Let me see what 21 says. Felipe, his savings account has a balance of $22.38 in it. After 3 years, what will the amount of interest be at 6% compounded quarterly? There's a slight difference to number 21. What's the slight difference?
Has a balance? So
That's
that's
a
at
balance
negative?
already.
Is that negative 220?
Mm-mm. Mm-mm. No, it's just saying this how much money he got in his account right now. That's his balance. And he says after 3 years, what will the amount be if he invested it and has some interest for 6%?
He already has some in there.
Well, you already have something.
Okay, well, let me ask you a question. Are you going to use the same formula in number 19?
Wait, why is it less?
Yes. Why you mean why is it less? What's less?
The values.
What value?
The answer choices.
Yeah, I'm not getting the right answer.
That is interesting that the answer choices are less. Well, let's see what the question asks. It says after 3 years, what will the amount of interest be?
Oh, so you subtract.
Aha. They ain't asking how much total money he's gonna have. They just wanna know how much interest he earned off of his money. So do we still have to use the formula?
Yes.
Yes. So I'm still gonna come up here and put, how much money did he have in his account? 2238 times 1 plus, what's the interest rate? 6%. 0.06 divided by compounding, how many times a year? Quarterly? That's 4, raised to the 4 times how many years? 3 years. So now you should put that in the calculator, and what do we get?
26.75.
Okay, so we end up with 26.75. Was it some change? 26.7, huh?
79.
And 79. Now, that's how much money he would have in the future, but how much interest did he gain?
Subtract the
You
220.
just
20.
subtract.
Quarterly? Quarterly, 4 times a year is quarterly.
Subtract the
Subtract the 26
75.
from the, and the 2238, and I get how much?
437.77.
This is how much interest that was earned. Subtract. Alright, so this was number 21. The one prior to that this was number 20. Questions while we're going through it? What questions do you have?
So you also subtract when you do the interest?
Yep.
Are you gonna put this formula up on the test?
I don't know.
It's serious, somebody needs to know, ma'am.
I'll ask you again in the email time.
Okay.
I'm gonna hit reply all and that's too, right?
Okay. Alrighty, so number 22 says determine whether the polynomial that you see the graph of is it cubic or quartic, based upon what we just learned. Is it cubic or quartic?
It's cubic.
Cubic.
It's cubic because it has two
Has
turning
two.
points.
No, it's quartic because it has 3 turning points. It has 3
Oh,
turning
yeah,
points.
y'all right, that's true, a turning point, so it's quarter.
It is quartic. It does have 3 turning points, so if you see your turning points, right, I'm trying to make my screen go down. If you see your turning points, you've got one right there, one right there, and one right there. So you've got 3 turning points, and so over here, the number of turning points you could have for quartic is either 1 or 3. So this is quartic. Question. You good? Alrighty. Number 23, it says state the degree and the leading coefficient.
Degree is 4, leading coefficient is 6.
Okay, well, what kind of function is it? Is it cubic or quartic?
Quartic.
It's quartic, and it has the highest degree of 4, and the leading coefficient is 16.
Quartic.
Should you expect it to be in the right order on the test?
No.
That's 22?
Yes, this is 23.
What was 22?
Quartic. Alrighty, you should not expect it to be in the right order on the test. All right, number 24 says predict the end behavior of the graph. Is it cubic or quartic? It's cubic. So, is it up on the left, down on the right, or up on? Okay, so you got your graph. You see it? Well, how do you know it's going to be up on the left and down on the right? Because of the negative sign in the front of x to the 3rd power. And number 25 says use a data tool or a graphing tool to find the cubic or quartic. It wants you to do quartic for number 25. So go and put that in Zuru for me, please, and tell me what equation is the right one. You got data. 2, 3, 3, 5, 5, 9, 6, 15, 7, 19. Put it in Zuru where? Under PR, change the degree to degree what?
3,
Which one? It's quartic
4.
4. Quartic. It says quartic right here. And look at your answer choices. They all got 4s as the highest exponent.
Why is 22 quartic?
Because it looks like this. Shape right here.
Oh, okay.
These are all, both of these are quartic.
I need to write those.
And 24 was what again?
It's x to the third power, so it looks like these two. So which one is it? It starts negative, so it's gonna be this one.
Oh, so it's B,
Up on the left, down on the right.
24.
Up on the left, down on the right is gonna be B for number 24. Y'all do know the answer key is at the bottom of the page, right? Okay, just checking. Just checking.
I don't like this.
Oh, you trying to make sure you know it before?
Yeah,
Okay,
it's
so you practice it. All right. All right, did you, somebody put the data in?
I got A.
A.
Y'all got A? Did it come out looking just pretty much just like that?
But you had to move the
You had to
decimal,
move the decimal.
cause it says negative 1. you had to
Okay,
move the
good. I'm just trying to make sure y'all knew if you see 10 to the negative 1 power, you gotta move that decimal one place to the left.
10 to the 1 power. 10 to the negative 1 power.
You know if you get an answer and it's got a whole bunch of numbers with 10 to the negative 1 power? Let me let you see it so you'll know what I'm saying. Hold on. Hold on, let me actually put that one in. All right, somebody tell me, read the data to me, somebody.
2, 3, 3, 5, 5, 9, 6, 15, 7, 19.
All righty. What was I looking for, quartic or cubic? So I'm gonna change my degree to a 4 and hit calculate. Calculate, what did it do? All right, there it is. Y'all see it at the bottom of the screen? So, because this negative 1 right here, see that 10 to the negative 1 power? Because of that, I gotta move this decimal one place to the left. So it's gonna be negative 0.1833. How many decimal places did the answer choices give?
Probably 4.
Well, let's look.
Oh, 3.
Let's see. Okay, it did two decimal places. So you rounded to 2 decimal places, so we go back to zero again. We had to round this to 2 decimal places. So you would negative 0.18, 3.26 or 27, 20.02, 51.93, and 43 point, well, actually, that's gonna round up to 44. Let me go back and look at our answer choices again. Here we go. All right, questions? Guess what you get to do next? Use your cubic, do the cubic one.
So you just change that 4 to a 3 on 0.
Correct? And type the different data in and tell me which one is the right equation. Let me know when you got the answer for number 26 for the cubic. Make sure you change the degree to a 3.
B. I got B.
B?
Yes, because you moved the decimal,
Mm-hmm.
down this 1, and then it says negative 0.25 x squared
Okay.
minus 2.8 x plus 1.
Okay, we're we're good? What other questions do you have about this? You literally put it in there and pick the right answer for the equation. Last one, number 27, log base 8 of 32 says find the value of the logarithm without using a calculator. This one was tricky.
Yeah, what do you mean find the value? Don't you just put log 32 over log 8?
You could do that and put it in the calculator. I'm just saying it said don't use the calculator. So I don't think I have one on there like that you couldn't use the calculator. So if you put it in the calculator, what's the answer?
It's gonna be,
I did that log divided by,
What'd you get? Log 32 divided by log 8?
I got 1.66, then I divided every fraction on there and got the right answer.
Okay. Some calculators will let you, it'll pop there. Huh? Huh?
Don't you just convert it to the fraction?
I did convert it. It still won't. We're gonna convert it to a fraction, but still the question is, does it give you the answer that you're looking for once you convert it?
Yes.
So if I convert it to a fraction, here's my fraction that I'm gonna convert it to. When I say convert, that's what I meant. Is that what you meant?
Oh, no, I thought you meant the answer that I got from that into a fraction.
Oh, yeah, you can convert it, but if you put it in your calculator, you're gonna get a decimal value in most cases. Some of you already have it, so your calculator will produce a fraction for you. If it didn't produce a fraction for you, you gotta figure out which one of those numbers is that decimal number you got. You see what I'm saying? So if it said 1.5, you gotta figure out which one of those equals 1.5.
Oh, without using the calculator is what it said?
Well, I'm not gonna have you do it without the calculator. But I'm saying if you went ahead and used the calculator, now you gotta figure out what answer did you get?
5 over 3.
Oh, yours came out exactly as a fraction?
Well, I just turned it in.
Okay, so you turned it, yeah, that's fine, and it's the correct answer. Here is how they wanted you to do it without the calculator. It was tricky, it wasn't something, because it didn't come intuitively like me, I had to play with it for about 2 minutes before I figured out what they wanted me to do with it. They wanted you to rewrite this as 2 to the 32, well, let me put this back, so you'll see what I did. They wanted you to rewrite log of 32 as log of 2 to the 5th power. Because I knew that 32 is 2 times 2 times 2 times 2 times 2. Okay? They also wanted you to do this.
Oh.
Log of 8 is 2 times 2 times 2. Okay? Now, we learned about properties. When you got exponents, can you pull a number in the front? They wanted you to rewrite, put the 5 in the front. Can I put the 3 in the front? Can I cancel the log of 2's out? That was what they were. That was a tricky one, because I had to think about that one myself for a second before I figured out what I needed to do with it.
So you put that one on the test?
No, I wouldn't make them tricky, because you had to think about this one. I just wanted you to have the practice of it, but that's how they wanted you to do it if you didn't do it on your calculator.
But you said on the test, you have to use your calculator.
Yes, you will be able to use your calculator. Absolutely. All right, did everybody sign the sign-in sheet? Where is the sign-in sheet? All right, when is the test again?
2 days.
What time is the support class?
Test is Wednesday. Test will be everything we just did on the study guide. So anything on the study guide we've covered or anything we talked about today, you should know it's gonna be on the test. So study the study guide.
Like 16?
Same as always, 16. So test on Wednesday. The 5:30 class is the support class before this one, where they'll go back and ask me all the questions they want to ask me before the test.
Oh, okay.
So,
Yeah, I needed to come.
You
when I
need to
got
bring a
class.
drop over here. Stone.
Yeah, like somebody's super behind. I'm behind on the laws, all that stuff.
well, good thing we went over the study guide today, right?
If you like me, I follow them.
We all got a story to tell, right?
Yep.
Yeah, we all got a story to tell.